welcome to day 6 of our Unit 7 notes on dividing segments proportionally. So today's lesson is going to be us dividing segments into what we call a 1-to-1 ratio by finding the midpoint, which we actually know about from prior units, and then how that looks if we want to divide something into thirds or fourths or fifths and so on and so forth. So just a nice little recall here, we know our midpoint formula is the average of the x's and the average of the y's. So what I mean by that is we add our x's together for each coordinate, divide by 2, add our y's together, divide by 2, which makes sense because the average is the middle, hence the midpoint. So our midpoint formula can be used to find the midpoint of a segment. Finding the midpoint of a segment divides a segment into equal parts, which then have what we call a 1-to-1 ratio. So starting off pretty basic here, if I have A at -6,4 and B at 4,4, where would point C be so that it divides AB in a ratio of 1-to-1? All right, so let me plot this to get a nice little visual example here. So we've got -6,4, and then 4,4. And I'll just draw my line here. Okay. Now, a 1-to-1 ratio is, as I mentioned up above, the same thing as a midpoint. So in the question above, C is representing our midpoint. Now, using the midpoint formula, I can take the average of the x's, so that means add those together, which would be -2 divided by 2. Average of the y's, so 4 plus 4 is 8. And that would give me the coordinate -1, 4. And I'll go ahead and plot that. Now that looks like it makes sense because if you look at how this whole segment's broken up, it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then altogether is 10. So for every 5, there's another 5. That's your 1-to-1 ratio, where each part is half of the whole. So think about this as 2 parts, where each half is, well, 1/2 of the whole. All right, so likewise, maybe instead of a horizontal segment, where it's pretty easy, let's say I make it a little bit more on an angle. Okay, so like I said, we know that we can find the midpoint, which is, again, splitting it in a ratio of 1-to-1 by doing the average of the x's. So -4 plus 12 is a +8 divided by 2. 5 plus 13 is 18 divided by 2 is 4/9. So let's see, that falls here. Now, does that look like the midpoint? We talked about this earlier in the year. If you kind of use slopes to help you out, it looks like I have created 2 equal right triangles where I'm going over the same amount as I'm going up each time. That's just using my slope. And that is then in a ratio of 1-to-1, where each part is half of the whole. Now, let's see how this relates to similarity. What if you created this whole right triangle here? Okay, where I can see that the distance across here, or your change in x, how much you went from side to side. Well, I went from -4 to 12, which is 16 units. So if you count 1, 2, 3, 4, plus the additional 12 over here, you went 16 units. And then likewise, 1, 2, 3, 4, 5, 6, 7, 8, we went 8 units in your y direction. Okay. Now remember how I said the midpoint is the halfway mark? Well, look what happens when you take half of 16. We know half of 16 is equal to 8. So from here, if I go over 1, 2, 3, 4, 5, 6, 7, 8, and then half of 8 is 4, so 1, 2, 3, 4, actually end up at that midpoint, where now I've created essentially 2 similar triangles. And that's how this relates to our similarity unit. So we're essentially using a scale factor here of 1/2. Now midpoint's obviously pretty easy. You don't necessarily need all that explanation. You could just find the average of the x's and your y's, or you can look on your grid and kind of be able to find it that way. Some of the problems we'll do today are not as easy as that, so that's why I'm trying to relate it to this process, which will become a little bit nicer later on. All right, so nice little, again, refresher from the beginning of the year. Let's say I give you a segment AB with M being the midpoint and A being 2, 2, M being 5, 6. I want the coordinates of B. So what we did earlier in Unit 0 is we drew a line segment. This is A, this is B, this is M. Now I know A is the coordinate 2, 2, and M is the coordinate 5, 6. I want to know what B is. Now, we talked about how to get from 2 to 5, we had to add 3. So then I'm going to do the same thing for my x's and add 3 again, and that's how we end up with an x coordinate of 8. Okay, now likewise to get from 2 to 6, oops, I totally messed up. Oh wait, no, I'm fine. I misspoke. Alright, to get from 2 to 6, we added 4 to our y's, and then if I add 4 again, we would get 10. So we would find that the coordinate of B is 8, 10. Well, why does this method work? Why does it work that when I add 3 to my x's and 3 again, I end up at the other part of that segment? Like, why does this method work over here? Well, let's look at our grid. Ooh, okay. So if I have A at 2, 2, and M is at 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this whole idea of taking this segment and looking at how the coordinates moved is what helps me figure out this method on the right-hand side. Well, it looks like I went right 3, which is corresponding to the purple, which actually, let me change this to purple. I go right 3, and then up 4. So then the middle of that would be repeating that same process. So if I go right, 1, 2, 3, and then up, 1, 2, 3, 4, which is really just using translation. So this is all coming together. Oops, it says what are the coordinates of B? Sorry, this is supposed to be M, that's B. We land at the same point of 8, 10. Okay, where each part of this is 1/2 of the whole segment in a ratio of 1 to 1. Okay? Alright, so that's how we would do 1-to-1 ratios or midpoints, which again should sound familiar to the beginning of the year. Alright, so let's amp it up a little bit. I want to find point C that partitions the segment. So partitions means splits the segment AB with endpoints A being at -7, 2 and B being at 9, 10 into a ratio of 1 to 3 with C1, so we're going to call the C1, being closer to A than to B. Okay, so first let's get a little visual here. So there's A at -7, 2, and then B, 2, 4, 8, 9, 10. There's B at 9, 10. All right, so when I read the ratio of 1 to 3, just like how 1 to 1 I said was 2 total parts, 1 to 3 is 4 total parts. Okay, so think about this. You think of your segment AB split into 4 total parts, so 1, 2, 3 dashes in between. Now it's split into 4 parts. They're looking for what we're going to call C1, which is closer to A than to B in a ratio of 1 to 3. So the easier way of thinking about this is this guy is 1/4, so it's like a scale factor of 1/4. This is 1/4 of the total segment. Okay, so what you could do is find the midpoint and then find the midpoint again. So let's go ahead and do that. So from a visual standpoint, you might be able to locate the midpoint, but if not, we know that we can find the average of our x's, average of our y's. So it'd be 9 minus 7 over 2 and 2 plus 10 over 2 for the whole segment. So that's 2 over 2, 12 over 2. So I'm finding that coordinate to be 1, 6. So if you want to call that M, that's the midpoint of that segment. And then from there, you could find the midpoint again, which that, or you could even use some visual inspection here. That looks like this is the midpoint because I can use slopes to figure that out. It goes over 1, 2, 3, 4, up 2, 1, 2, 3, 4, up 2. We talked about that earlier in the year as well. Oops, I think it's like jumping on me today. So that's at essentially the quarter mark. Now I can do the same thing by continuing this rise over run pattern to figure out the ratio of 1 to 3 where C2 is closer to B. Okay, so over 1, 2, 3, 4. Let me zoom in. 1, 2, 3, 4, up 2, so it's like there. 1, 2, 3, 4, up 2. My line's just like slightly off when I drew it with my computer. And there's C2. So just using slopes and some visual inspection, I'm able to figure that out. And that's the coordinate of 5, 8. All right, now lastly, into a ratio of 1 to 7, where C2 is closer to A than to B. Okay, so again, 1 to 7 is 8 total parts. So if this is A and this is B, 1, 2, 3, 4, 5, 6, 7, we'll pretend those are all equal. You want C3 to be right there, which is 1/8 of our full segment. 1/8 is half of 1/4, which is what this guy was, so really your C3, maybe I'll use pink here, make it stand out, is right there at -5, 3. And that's how we can use midpoint to really partition our segment into obviously halves, fourths, eighths, really any multiple of 2 there. Now, what if we want to do something like a ratio of 1 to 5, like our next example? So find C on the directed line segment from A to B that divides AB in a ratio of 1 to 5. So that's 6 total parts. Now, 6 total parts is not going to be really doable with midpoint, so we're going to have to come up with another strategy. Okay? So, first of all, let's get a visual of what this looks like. So A is at -3, 11. Black again. -3, 11. And B is at 12, -1. Okay, so they call this a directed line segment. It's on an angle like that. Okay. Let me zoom out. Okay, so we want to find C so that it breaks it up into a ratio of 1 to 5. So let's think about this. This is A and this is B, and we're breaking it into 6 total parts. So 1, 2, 3, 4, 5. And notice how it says from A to B. So that means C must be closer to A. I want to find where that is. Now with C, that is 1/6 of the original length. So in order to find the 6th location on here, I'm actually going to relate this to what I did on the previous page and create a right triangle. Okay, now let's look at how our x's changed. All right, so how did we get from -3 to 12? So my change in x, that's our side to side here. Now you could either use the coordinates of -3 to 12 and figure out the difference there, or literally count. So we got 12 and then additional 3, so this is 15 units. So to get from A to B, we went 15 units to the right. Now to get from 11 to -1, it looks like we went down 12. So I'm going to say, going down this way. Don't love how that highlighted, but that's okay. I'm going to say my change in y, so how I went was -12. Okay? Now just like on the previous page, where I said things were cut in half along bottom, 16 divided by 2 is 8, and 8 divided by 2 is 4, and that's how I could find point C. I'm going to use that same idea. From A, I'm going to cut everything into a sixth. So here's how my x-coordinate from A is going to move. My change in x, so how much I moved from side to side, was 15, right? But then I'm going to take 15 and multiply by 1/6, because that's where C is. It's 1/6 the way in the horizontal distance. Now, that doesn't work out nicely. I'm just going to grab my calculator here. So 15 times 1/6 ends up with 2.5. Now how my y's are changing, I'm also going to scale that, where I take how I went down by -12, but then I multiply that by 1/6. That's -12 divided by 6, which is a -2. So from our coordinate A, which is -3, 11, I'm going to take this 2.5 and tack it onto my x's, because that's my x change. And then I'm going to tack on the -2 to my y's. And that'll help me locate C at -0.59. Now, here's why this makes sense. What this is saying from A is that you are going down 2 units, and then to the right, what appears to be 2.5, which actually kind of makes sense on my grid here, and that's how we end up right about where -0.59 is. So essentially, I'm just scaling my horizontal distance side to side and my vertical distance up and down by whatever this is, and then tacking it onto my first coordinate. Now, some of you guys will be able to figure out this process without drawing the picture, and some of you guys may need the picture, but ultimately that's what we're doing. All right, so let's try another one. So given the points 10, 10, so that's this guy right here. Oops, I'm going to try and be consistent, keep it in black. 10, 10, and then Q's at 0, 4. Q, 4, P is at 10, 10. Okay, there's my segment. It says find R and PQ such that PR to RQ is 7 to 3. So this is just phrased a little bit different. Okay, 7 to 3 means there are 10 total parts. Okay, so I'm going to switch it so that it makes sense with the way that I drew mine. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 tick marks, but then split that into 10 total parts. Now notice how it says RQ is the 3. Okay, so that means from Q, that's 1, 2, 3. So this is 3/10 of the original segment. Okay, so that's what I'm going to scale everything by. Okay, so essentially I need to find where the 3/10 marker is on this segment. Okay, so just like the last example, I'm just going to create a right triangle to help me see how my x's and my y's changed. Or again, some of you guys might be good enough just to see from the numbers to get from 0 to 10 on my x's. I just added 10. Okay, similar to that midpoint problem up before, I just noticed how my x's changed. Now, how did my y's change? To get from 4 to 10, I had to have added 6, or just count here. So in the y direction, I went up 6. Okay, so now let's do a little bit of math. Okay, my x coordinate starts with how much I went across, and then I multiply by 3/10, because I want to find where 3/10 is on here, because that's going to help me get in this vicinity. 10 times 3/10, well, the 10s will cancel, that's a 3. In my y direction, again, my y's originally changed by 6, but now I'm going to multiply that by 3/10, and that gives me, well, the 10 times the 3/10, that's not going to work out too nicely. Let me grab my calculator. 6 times 3/10 gives me 1.8. Okay, so from Q, which is this guy right here, that's the beginning of our segment, we're going to add 3 to the x's and add 1.8 to the y's, and that means R should land at 3, 5.8. Now let's see, does that make sense? By saying we're going to scale this by 3/10, this means you move to the right from here 3, so 1, 2, 3, and then up what appears to be about 1.8, so that location of R kind of makes sense. That does look like it could be about 3, 5.8. All right, find the point on the directed line segment from A to B, where A is at -5, 3, B is at 10, 3. So sometimes it just gets people, just because like they're used to doing them diagonal, they forget how to do it, just when it's horizontal or vertical. Okay, so technically what you're looking at here is just a horizontal line, so there's no like change in y, like it's just side to side. It says I want to find C so that it splits it in a ratio of 2 to 3. So this is 5 total parts. Okay, so if you think about it, if this is A and this is B, 5 total parts would be 1, 2, 3, 4. That would split it. Here's where the 2 is. So then C is the 2 units away from A, and then technically CB is 3. But from A, that's at the 2/5 marker. Okay, so let's see, this is 1, 2, 3, 4, 5, plus another 10. This is a 15 total units across. So if you want to label that as change in x is 15, ultimately what I just need to do is find what 2/5 of 15 is. Okay, so that would be 30 divided by 5, which is 6. So that means here, guys, 1, 2, from A, 1, 2, 3, 4, 5, 6. You could use the grid to find it. There's C. Or even just use your coordinate. Remember, A was -5, 3, so if you're adding just to the x's because it's horizontal, you'll end up with -1, 3 in the exact same way, and that's your coordinate of C. All right, now I switch it up on the next page because of the language I use. It says, given A and B, find the coordinates of point C so that it sits 3/8 of the way along AB, closer to A than to B. So notice how I'm not giving you a ratio. This is a ratio. Find C such that AC to CB is 2 to 5, or 2 to 3, so you'd have to know that's 5 total parts. This is saying you're actually using 8 total parts. I want you to find where that third part is, okay? So, if you were to sketch a picture, here's A, there's B. 8 total parts is 1, 2, 3, 4, 5, 6, 7 little dashes here. So it says sits closer to A, so we're looking for where this is right here. 1, 2, 3, because that's where the 3 is. So this actually is a little bit easier. You didn't have to figure out using the ratio what that little scale factor is or what you're multiplying by. You're just simply using the numbers that they're giving you. Okay, so some of you guys will be able just to figure out your change in x and y from the coordinates. You could even use a little graph to help you. Or I'll actually draw the picture too in case you struggle with that. So A is at -4, 5, which is right there. B is at 12, 13, so that's like right there. Ooh, I meant to do a line. That's actually not too bad. I feel like that was pretty straight. I was trying to use the line segment tool. There we go. All right, so there's my line segment tool. So remember, you're trying to find what 3/8 is. Okay, so I can draw a right triangle to help me figure this out. So how did my axis change? Okay, so you could either count along the bottom here or just use those coordinates. You got from -4 to 12, so you must have added 16. Now to get from 5 to 13, you must have added 8. Again, that's just how many units this is. These are the numbers that I'm then going to scale by 3/8, because if I can find 3/8, that'll get me like here, find 3/8, that'll help me find this coordinate, at least to check. Okay, so in my x direction, I'm taking my 16, multiplying it by 3/8. Now 16 divided by 8 is 2, times 3 is 6, but you guys can always use your calculator to help you. In the y direction, I'm taking 8, multiplying by 3/8. 8 would cancel, and that would result in a 3. So from this coordinate A right here, which is -4, 5, this is saying essentially add 6 to your x's, add 3 to your y's, and that's how I end up with the coordinate of C being at 2, 8. Now again, you can use the grid to kind of help you here. Does this make sense? From A, if you go to the right, 1, 2, 3, 4, 5, 6, and then go up 1, 2, 3, that perfectly makes sense. That's where your point C is, which is the coordinate 2, 8. All right, given points A and B, find the coordinate of D. That is 3/8 the way along AB, closer to B than it is to A. All right, so there's a few ways to think about this. This is A and this is B, again, 3/8. 1, 2, 3, 4, 5, 6, 7. Closer to B would be 1, 2, 3. That's right here. Now you honestly could work backwards from B, or think about how from A to C, because then it's like the same logic up here. That's just 5/8. Okay? So, I actually don't even need to redraw this picture. It's the same picture up above. I can take my change in x, which I had already figured out from up above, because this is the same segment, is 16. And then I'm going to multiply that by 5/8. So 16 divided by 8 is 2, times 5 is 10. Same thing with my y's. My y's changed by 8. I'm going to multiply by 5/8. So those would drop out, and that leaves me with a 5. Now starting from A, which has the coordinate -4, 5, I'm going to add 10 to my x's, add 5 to my y's, and that ends up with 6, 10. Now let's see, does that make sense? Oops, sorry, it's not C, it's supposed to be D. If I come back up here, because I already have this graph, so why not? This means from A, we went to the right 10 units, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going this way. And then up, 1, 2, 3, 4, 5. Oh, look at that. That's working out perfectly. There's our point D. So again, what this is saying now is that the relationship is this is 3/8 of the original. Likewise, from before, this is 3/8 of the original. So this is kind of nice because I didn't have to find, I mean, if you think about it, 8s, you could have just found the midpoint multiple times and split the whole segment up and then found it, or just multiply by what you need. So this is actually quicker than this example, in my opinion, where I'm just finding the midpoints all over the place and dividing it. All right, we got one more example to do. Given points A and B, find the coordinates of C. That is 3/4 the way along AB, but it says it's closer to A. Okay, so A, B, 3/4, so that means it's split into fourths. 1, 2, 3, 4. 1, 2, 3. It says it's closer to A though, excuse me. This is kind of funny worded, but that means the 3/4 is over here. And this, from A, is actually 1/4. Okay, so A has the coordinate -6, 8. B has the coordinate 2, negative 2. Okay, I'm going to create that triangle to help me figure out how my x's changed and how my y's changed. Ooh, that was a pretty straight line. All right, so my side to side. To get from negative 6 to 2, or just, again, you can count along the bottom here, it looks like we increased by 8. Our up and down to get from negative 2 to 8, or again, just count, looks like we increased by 10. Or sorry, decreased by 10 to get from 8 to negative 2. I got to be consistent reading it from left to right here. So negative 10. Okay, so now those are the numbers I'm going to use with my scale factor of 1/4. Okay, so with my x's, I'm taking 8 and multiplying it by 1/4. 8 divided by 4 is 2. With my y's, I'm taking negative 10, multiplying it by 1/4. And that would give me a negative 2.5. Okay, now remember, it's from A here that I figured this out. So from A, which has the coordinate of negative 6, 8, I'm going to add 2 to my x's, but subtract 2.5, and that's how we land with our coordinate C being at negative 4, 5.5. Again, does this make sense? Go to your grid. From A, it's like you're going down 2.5 because that's in your y direction. So 1, 2.5. And then you're going to the right 2, and that fits perfectly right there. And that's your coordinate C. And that is directed line segment. So it relates to similarity because it's like this is your scale factor that you figured out. And this triangle's segments are 1/4 of the original.